Hello, and welcome to today's lesson, our last lesson in the first unit of Algebra Skills and Geometry Foundations. By the end of this lesson, the goal is to define the segment addition postulate and solve problems using that postulate, and then also define the overlapping segments conjecture and solve problems using that conjecture. So when we look at the segment addition postulate, if we have a full segment from A to C, what we understand is that we can cut this segment up into parts, and as long as the parts are connected, they have a shared point of B. So from A to B, and from B to C, if we add those pieces together, we end up getting the full segment from A to C. Okay, so always in these situations, make sure that you draw a picture. The picture is one of the most important parts to see what's happening, to fill in the information, and to understand what the information represents. So if we're going to apply it to this situation here at the bottom, if we know that from A to B is 7 feet, and from A to C is 19 feet, okay, then it's easy for us to figure out how much this last segment is. Okay, we can set it up algebraically if we wanted to, but hopefully in some of these situations you can look at the numbers and see how they connect to each other to give us BC equals 12. Okay, once again, if you're unsure, what you want to do is define what you're looking for or what's missing as a variable, and understand that 7 plus x is going to equal the full length of 19, and then we subtract 7 from both sides to get x equals 12. Okay, so now, using algebraic equations in this situation is no different. Okay, it just requires a little bit more work. So now, if we know that from A to B is 6x minus 3, from B to C is 4x plus 5, and then we're told that the total distance from A to C is 32. Okay, so we want to look at and see, understand how the equation builds in this scenario. So the full distance is 32. Then we know that the two pieces that make up that distance, 6x minus 3 plus 4x plus 5 equals 32. And now we're just going to do some algebraic solving. We always want to combine like terms first, so we combine the x's to get 10x, combine our constants to get a plus 2 equals 32. Okay, and then we finish our solving steps. Whenever we solve, we're undoing operations, so we undo the addition. We've got 10x equals 30. Now we need to undo the multiplication by dividing by 10. And we end up with x equals 3. Okay, so now we know what our x value is, and then we can use the equations to solve for the two missing lengths. 6 times 3 is 18. 18 minus 3 is 15 for our length of AB. And then when we look at BC, 4 times 3 is 12. 12 plus 5 is 17. So you always want to draw the picture, understand, do the pieces fit together to make a full length, or, as we're going to see now, we're going to see some situations where there is an overlapping piece. One extra example here. Okay, we'll run through this one pretty quick. We've got our AB of 2x plus 7, BC of 4x minus 3, and now the full length is given to us as an equation as well, 3x plus 16. Okay, but once again, understanding that the two parts add together to make the whole distance. And then from there, we combine like terms, combine the x's, combine the constants, and now we've got variables and constants on both sides. Okay, so you want to move your variables to one side. So I'm going to do that by subtracting 3x from both sides to move the variables to the left. And then I have to subtract 4 from both sides to move the constants to the right. And then we can divide out to finish, and we get x equals 4. And we divide by 3 on both sides. Okay, now since we have equations for all of the pieces, we want to put the equations in play to find the values that are missing. So AB, 2 times 4 is 8. 8 plus 7 is 15. BC, 4 times 4 is 16. 16 minus 3 is 13. Okay, now our next conjecture that we're looking at is the overlapping segments conjecture. Once again, always looking at the picture here, drawing the picture so you can see what's happening overall. Okay, we're told, and this is told to us by the tick marks, okay, also in the sentence above, that AB is equal to CD. Okay, so we have this given information. Then what we know is that from A to C, notice it's not the entire distance, is equal to B to D. Okay, now, why does this work? Hopefully you can see the overlap. This overlapping segment from B to C. Okay, so this entire segment here is shared in both of those situations. So since it's the same segment shared on both sides of this equation statement, we know that it's an equal segment lengthwise. So now let's look at some situations that would apply this scenario, okay, this conjecture. So we're told that AB equals 7. Okay, once again, always try to identify what distance is given to you there. Okay, from A to D, so now we've got the full length is 25. Okay, we need to find some of our missing pieces here. We need to now know what BC is. Okay, so that's one piece that we're looking for. And then we also want from B to D. We want to find that distance. Okay, so now there's some missing pieces in this situation. We know the 7 over here with the 2 tick marks. So what we have to do is put the 7 over here because it matches with the 2 tick marks. So now we have the 7 and 7 on both sides, which gives us 14. The entire distance from A to D is 25. So if we do 25 minus the 14, we now know our BC length. We've taken the 2 end pieces that are equal to each other away from the total distance of 25, and that gives us our BC distance of 11. And now that we have every piece accounted for, we just add up the pieces for BD is BC plus CD equals the total distance of BD. Okay, one more example here using some algebra, and then we're pretty much wrapped up for the lesson here. But always draw the picture in your notebook. We're always filling in what we know. So in this case, we know what BC is. Okay, BC is 3x minus 3. Okay, so we're putting an algebraic equation in that spot. We know that CD is 2x plus 4, and remember that's the 2 tick mark designated length. So even though we're not told what AB is, we know that since this is a 2 tick mark designated length, we need to copy this length over to the left-hand side as well. And then we're given the full distance from A to D is 33. Okay, so now we want to look at the picture. What segments do we have? Are any of them overlapping that we have to be careful with? In this case, we're given segment 1, segment 2, segment 3. All of those segments are going to add together. Okay, there's no overlap that we have to worry about taking away any values. We're given the 3 separate segments that all add together to give us the full length of 33. And then we just go through, once again, combine like variables since they're all on the same side. So we have a 4x and a 3x for 7x. Then we go through and combine our 3 constants. 4 plus 4 is 8. 8 minus 3 is a plus 5. And now we're going to work our way through and finish our solving. Undo the addition, gives us 7x equals 28. And divide by 7, we get x equals 4. So now we know what our variable is. Okay, x equals 4, and now we're going to plug that in to solve for these missing lengths. So for AB, it's 2 times 4 plus 4 gives us an AB length of 12. 2 times 4 is 8. 8 plus 4 is 12. And then for our BC length, 3 times 4 is 12. 12 minus 3 is 9. So notice, this picture is not drawn to scale based on what we see here, because we know based on the picture it looks like BC is longer than AB. Here what we have to do is make sure that we're trusting the algebraic work that we've done to go through and solve for that situation. Okay, now, last one here, last example, always looking at how the pieces are built together. So now we've got BC, 3x plus 5, AB, 4x minus 2, and we're given AD equals 3x plus 17. Okay, now if we notice on top, we have a missing piece at CD, but since CD is a 2 tick mark side length, we can fill that in with the equal to equation from the other side. So now we're doing the same thing that we did in the last problem, but instead of equaling a number, it's now equal to another equation. So we have 4x minus 2 plus 3x plus 5 plus 4x minus 2 equals 3x plus 7. Okay, we combine like terms. Jumped ahead of myself a little bit there. 4x plus 4x is 8x. 8x plus 3x is 11x. Combining our constants, negative 2, negative 4 plus 5 is a plus 1 equals 3x plus 7. And then we have to get our constants on one side, so I'm going to move the 3x to the left by doing the opposite operation. 8x plus 1 equals 7, and then I subtract 1 from both sides. Okay, 8x equals 6. So we divide both sides by 8, and here we're going to get a fraction, and sometimes fractions happen. Okay, now, I reduced the 6/8 to 3/4. I just did that in my head, but remember, we always want to think about, is there anything we can divide the top and bottom by to make the value smaller, we can divide them both by 2, and that's what got us down to the 3/4 for x. Okay, once we have that piece, then we can go through and solve for what we're looking for, solve for those final situations. Okay, so x equals 3/4. If I'm looking for CD, okay, 3/4 times 4 minus 2. Okay, so 3/4 or times 4, which is 12/4. 12 divided by 4 is 3. 3 minus 2 equals 1. Now, if I want the AD length, okay, then we're having to multiply that out as well. We've got 3 times the 3/4 plus 7. Okay, so 3 times 3 is 9, so we have 9/4 plus 7. 7 is equal to 28/4. So then we add those pieces together and we get 37/4. Now, if we want to break this down into a mixed number, we can say 9 1/4 for that value. That concludes today's lesson. Good luck on the homework and have a great day.